Now you already know that how does a breadth first search works. Breadth first search is typically a notion where we move out in the breadth before moving out in the next iteration. That is exactly the opposite of what depth first search is. And in the DFS, we go or we pick a branch, we iterate all the possibilities of that branch while keeping track of the nodes that we have iterated over. And when we run out of all the possibilities, we are going to do a backtrack and see if there are any more possible ways where we can iterate over. If there are no possible ways exist, we are going to backtrack again and then move on to the next values in that particular subsequent branch before backtracking to the previous root node again and iterating the same process for the remaining portion of the tree. So that is exactly what we are doing here, where you see that first we iterated in the depth in the left side of the subtree. So we iterated through all of this path. Then we ran out of all the possibilities because there were no children of this node. So we backtracked. There were no nodes that we forgot to cover. Again, we backtracked. We covered this portion. Again, after existing all the possibilities, we again did a backtrack and moved on the right side of the subtree and keep on repeating the same process until we run out of all the nodes. And eventually we would backtrack and come back to the root node. And this is how DFS typically works in a tree. Now for a tree, there are three main methods, and that is Inorder, Preorder and Postorder that I'm going to talk about next in this video. So first we are going to start with a Preorder traversal. Now what does a Preorder traversal means? Now first understand that from any given place we have two possibilities. First possibility is we go either left side or left subtree. Second possibility is either we go on the right subtree. And there is a possibility that when we are going to do some process on the node currently we are at. And that is what this preorder, inorder and postorder, all of these three techniques do. That it allows us to determine that when we are going to process the node we are currently at. So in the preorder traversal, we are going to process the node first. In the inorder traversal, first we are going to go in the left, then we are going to process the node, and then we will go in the right. In the postorder traversal, first we will go on the left, then we will go on the right, and in the end we are going to process the node we are currently at. So this is what all of these three techniques refer. So first let's see the preorder traversal in action. So in the preorder traversal, the flow is going to look like this. That first we are going to visit the node. So first thing is going to be the node. Then we are going to visit its left subtree, and then we are going to visit its right subtree. So the flow is going to look like this. That we are going to start from the root node because that's a given fact. We are going to visit the node. So first item we are going to do any action is going to be on the node number 5. Then we are going to visit the left subtree if there exists. And left subtree exists. So again, this is the entire left subtree. Again, even for the left subtree, we are going to repeat the same process. And the process is that again, we are going to visit the node first before visiting its left subtree and the right subtree. So again, the left subtree, currently the next node we are going to visit is going to be the node number 2. Again, for its entire left subtree, it only has one node. So again, we are going to visit node number 1 after that. After visiting node number 1, we are going to do the backtrack, and then for this node number 2 that we have already visited, we haven't visited its entire right subtree. So that we are going to do next, and the next node we would visit is going to be the node number 3. Now what happened is that now after this 4 iterations happen, we have taken care of the entire left subtree from the root, and we already took care of the root node, that was node number 5. So now we are going to take care of the entire right subtree. Again, even for the right subtree, we are again going to apply the logic of node, left and right. So again, this is the node. Currently, it does not have anything in the left, but we are going to visit node number 6 first. It does not have anything in the left, so we are going to move in the right. Again, for the right subtree, it has these two elements. So first, we are going to take care of value number 8 because node, left and right. And after that, in the end, for this node, we have the node number 7 that we have to take care of. So in the end, the last node we are going to visit is going to be the node number 7. So if we want to see the full traversal is going to look like this. And this is how we are going to move in the pre-order traversal fashion. Now let's see that what would be the in-order traversal looks like. Let me clean this up a bit. So for the in-order traversal, there is a slight difference. And the difference is, first we are going to iterate the entire left subtree, then we are going to visit the node, and then we are going to visit the entire right subtree. And we are going to recursively or iteratively keep on repeating the same thing for the entirety of the tree. So we are again going to start traversal from our root, but we will have to visit the entire left subtree before visiting the root node. So in the entire left subtree is going to be this one. But even for this entire left subtree, the same properties applies again. And again, even for this 2, we will have to visit the entire left subtree, and that is going to be the value number 1 only, because 1 does not have any more children. So the first node we are going to visit is going to be the node number 1. And then the next node we are going to visit is that we are going to do a backtrack. And since for this 2 we have visited the entire left subtree, so then we will visit node number 2. And then even for node number 2, we still have elements in the right side of the subtree that we haven't visited. So we are going to do that. The entire right subtree is only comprised of value number 3. So again, we are going to visit node number 3 next, and then we can backtrack. Backtracking from 2, now we have taken care of this entire portion, so we are not worried and we can go back. Now at node number 5, we can say that we have taken care of the entire left subtree for the node number 5. So it is safe to visit node number 5 next. We will visit node number 5. Then again, we are going to repeat the same thing. Now, even for the node number 5, it still has element on the right side of the subtree that we haven't visited. So we are going to repeat the left node right technique again for the entirety of the right subtree for this portion. So for this portion, since for node number 6, it does not have anything in the left side of the portion, we are going to visit the nodes. We are going to visit node number 6. Then again, for these 2 portions that is present in the right side of the subtree, we are going to repeat the same thing. So before visiting node number 8, since node number 8 has a value number 7 in the left side of the node, we are going to visit node number 7 first before visiting node number 8 in the end. And then we would have taken care of, or we would have visited all the nodes in the in-order traversal. Now, seeing from the solution that we have visited, you should be able to infer a very clear thing right now. And this is actually a solution of a very popular real-life problem. You see that all of these values, they are actually presented in a sorted array. And why they are presented in a sorted array? Because the tree that I draw over here was actually a binary search tree where I'm maintaining a property that every element on the left side of the subtree is going to be less than the root node, and every element on the right side of the subtree is going to be the greater than the root node. And this is present for every single node that has a left element and the right element, that all the values on the left are going to be smaller than the root node, and all the values on the right are going to be greater than the root node. And this is how a binary search tree is defined. And using in-order traversal on a binary search tree, we are actually able to generate the sorted array. And see, you just solved a very popular coding problem that is being asked in a bunch of companies. I'm actually going to show you the LeetCode proof that this question exists, and you already know how to solve it. All you need to do is do in-order traversal on a binary search tree to find the sorted result. But now let's just go back to our technique. And now let's see that what does the post-order traversal mean. And let me again clean everything up, and I'll show you the post-order traversal as well. Now in the post-order traversal, first we are going to visit the entire left subtree for any root node. Then we are going to visit entire right subtree, and in the end we are going to visit the node. So for the 5, what we are going to do is first we are going to visit entire thing on the left subtree. Then we will visit everything in the right subtree. Then in the end we will visit this node number 5, and we are going to iteratively or recursively keep on repeating the same process. So first let's see what would happen for this node number 5. We start at 5. It has elements on the left subtree that we haven't visited, so we go on the left subtree. Again, even for this 2, it has elements on the left subtree that we haven't visited, and that is value number 1. Now for this value number 1, it does not have any more left or right children, which means we are sufficiently able to visit this node. So first node we are going to visit is going to be node number 1. Then we are going to backtrack to its previous node, that was going to be node number 2. Again, even before visiting node number 2, we will have to visit the entire right subtree for that node. So we are going to do that, and that is going to be node number 3. So then we are going, after visiting node 1 and node 3, we would be able to visit node number 2. After visiting node 2, we will again backtrack to node number 5, stating that now for this node number 5, the entire left subtree has been taken care of, but it still has elements on the right subtree that we haven't taken care of, that we are going to work upon right now. So even for the right subtree, we are going to apply the same logic. So for this node number 6, since it does not has any nodes on the left, it still has nodes on the right that we haven't taken care of. So again, we are going to visit the right subtree for node number 6. So that is going to be node number 8. Even for node number 8, it still has elements on the left that we haven't taken care of, that is node number 7. So next value after visiting this node number 2 is going to be node number 7. After 7, we are going to visit node number 8. After visiting node number 8, we are going to go backtrack and visit node number 6. And in the end, we are going to visit node number 5. So what we did in this post order traversal is that we took care of all the elements that were present at the leaf before moving back to its like predecessor. And this would be the post order traversal for this tree.